Previously, I began the fourth presentation by talking about the history of the world, and now I'd like to focus here in part two of that last presentation. I'd like to focus in on the age of the Earth. And I'd like to note that I benefited from numerous sources, both written material and PowerPoint slides. I don't necessarily agree with every single source on everything, but certainly the information that I got from them was very helpful. So, the biblical view suggests that the Earth is young, less than 10,000 years old. The evolutionary view suggests that the Earth is old, 4.6 billion years, approximately. And I think it's worth noting that really evolution fails even if one had billions of years, as we've noticed in the first presentation, that even if one had billions of years to work with, it still wouldn't work. But let's focus in here on the age question. How long does it take for rock layers to form? We can see large layers of rocks around the world. How long does it take for those rock layers to form? And I think that's a good place to begin, because I think that's where people first began to get the idea that the Earth was old because of this perspective, uniformitarianism. Uniformitarianism suggests that the present is the key to the past. In other words, the idea is that we can look around the world today, and whatever processes we see operating here, well, we should just assume that those were the same processes that are operating in the past. So, for example, if it takes 40 years today for an inch of sediment to form, then it would take 2.4 million years, if I calculated right, to form 5,000 feet of sediment. And so if one has that uniformitarianism type perspective, or uniformitarian perspective, then of course one's going to reach conclusions like that. And you may know Charles Lyell held to this view and strongly influenced Darwin. On the other hand, a differing perspective would be catastrophism, which is held by, I think, a variety of different types of people. The present is not the key to the past because catastrophic events occurred and or had great geological type effects, and those we might not see operating around us today. Specifically, from the biblical perspective, the main catastrophe is the flood of Noah's day, which is responsible for most of the rock layers. Well, as evidence consistent with that, let me point out that I believe this is from Grand Canyon. There seems to be a lack, in many places, a lack of erosion and bioturbation. I believe that has to do with the actions of living things, like trees, send down roots, and animals dig burrows and that kind of thing, and so that tends to affect the ground. And yet we can see here that it hardly looks like anything has happened in between these two layers, and my understanding is that lower layer is supposed to be like an underwater deposit, and the upper layer is supposed to be like sand dunes or something like that, and yet it doesn't look like very much time passed in between those. Or here's a sort of a cross-section of Grand Canyon, and if you take a look at this very bottom kind of dark brown layer, that is supposedly 550 million years old, and yet about 70 million years ago it was supposed to have been lifted up here. And yet if you take a look here, you can see where here the rock layers have been bent vertical, and yet they're not all broken up. How could that be? How could it be that when rock layers that have been in the ground supposedly for hundreds of millions of years and are presumably hard by then, they don't bend like that? And so that seems more consistent with the idea that the rock layers were laid down quickly, and while they were still soft, then they were bent. Or polystrate fossils, that is, fossils that go through several strata or layers. And so you might have, let's say, a tree that goes through layers that supposedly took millions of years to form. Now, as you could see, that seems to present a problem, because if the tree is buried in the bottom layer, and then millions of years go by while the other layers are gradually accumulating, how come the tree didn't decay away? And how come you only you should find like a stump in the bottom layer and then nothing because it decayed away before the layers came along millions of years later? And I think really Mount St. Helens, the explosion and eruption there, I think that was really informative with regard to a number of these kinds of things. And so for one thing, we can see from Mount St. Helens that you can get rapid deposition of layers. So for example, these layers here, and you can see the person there sort of for scale, one deposit of more than 25 feet was accumulated in just a day. So it doesn't take a long time for large layers to form. There are some rocks from Grand Canyon, and there are some from Mount St. Helens, and at least to me, I'm not a geologist of course, but it looks to me like those are similar to one another. Then it's also worth noting that just as layers can be laid down quickly, canyons can also be carved quickly. So this canyon here, water was diverted into a ditch, and then look, in not very much time. Then there are some kind of worldwide things that we could look at. Instead of just looking at a particular rock or something like that, one could look at large-scale phenomena like salt in the oceans. And so my understanding is that because of rivers dumping water in and things like that, salt is being poured into the oceans. And so one could ask this question, well, let's suppose that the ocean was had no salt in it at first. How long would it take, with the processes that we observe going on today, how long would it take for that salt to accumulate? And my understanding is it would accumulate in a maximum here of 62 million years. Now, of course, that doesn't mean that it took 62 million years, because the oceans were probably created salty to be in the beginning. And so it wouldn't actually take that long, but clearly that is inconsistent with the idea that the Earth is 4.6 billion years old. Or, to look at it another way, written history. Human beings, according to the evolutionary model, have been around for a long time, and yet how is it that written history only starts about 5,000 years ago? Did it take that long, even though they could build remarkable things, do paintings and carvings on cave walls and things like that? How come it took that long to start writing? Or this, to move beyond the Earth here just for a little bit. Here's an interesting one, the winding up dilemma. You know, as we look out into space with things like the Hubble Space Telescope, we can see beautiful spiral galaxies like this one here. And yet, the stars, of course, moving around are moving at different speeds. And so it wouldn't take very long, relatively speaking, wouldn't take very long for those spiral arms to kind of be removed, and it would become sort of a featureless region of stars. My understanding is it's supposed to take no more than about 500 million years. Now, of course, that doesn't mean that it really took, or that 500 million years have really gone by, because it could have been created like that in the beginning. But that's clearly inconsistent with something being billions and billions of years old. Or this one here with comets. You know, comets lose material as they go through each orbit, and then there's also the chance that they might be dislodged. And it doesn't take very long for those kinds of things to happen. Comets should have disappeared if the solar system were really billions of years old, and yet we still see comets. And so how can that be? And some scientists have suggested, well, maybe there's a cloud called the Oort cloud way out beyond the orbit of Pluto that has objects that could become comets, and every once in a while something gets knocked out of that cloud and it becomes a comet, and that's the reason why we still see comets. And that, of course, is just an assumption to explain the fact that how can it be that we still have comets when it seems like an old solar system is inconsistent with the presence of comets. Well, let me turn to some problems for the young Earth perspective. One problem that people sometimes speak of is the problem of distant starlight. If a star is millions of years, or millions of light years away, then how is it that we can see the light if the Earth is, and the solar system is less than 10,000 years old? And some people seem to regard this as a serious problem. It's never actually struck me as that difficult of a problem. But let me give you some possible solutions. One possibility is that the light could have been created in transit. As you might recall way back in Genesis 1, that the sun, moon, and stars were created to give light and for timekeeping, days and seasons and things like that. And so it would make sense that, of course, they have to be visible from the Earth in order for that to to have happened, so the light could have been created in transit. Some people seem to think that that would be deceptive. I don't think that would be deceptive. Adam and Eve probably would have looked to be in their 20s or something like that if you saw them on the day they were created, but they really weren't that old. Or it could be that the speed of light is not a constant. Maybe the speed of light was much different in the past. And I understand that there's some work that seems to suggest that. And then there's Russell Humphrey's model. And since I'm not a physicist, I don't claim to be able to understand all the intricacies of this. But as I understand it, if you have like a bounded universe, then time moves differently toward the periphery than it does at the center. And so you could actually have long periods of time go by far away from the Earth, while relatively small periods of time are going by on the Earth. And I know that might sound strange to many of us, but apparently that's consistent with Einstein's theory. Well, what about radiometric dating, which I think is the main reason why some would say that the Earth is very old. And I adapted this from a slide that I got from one of those sources, I believe, and I appreciate that. And so, as you might know, with regard to radiometric dating, basically the idea is this. If you know that if you have these particular elements, sometimes called parent and daughter elements, where the parent element over time decays into the daughter element, then you can estimate the age if you know a number of things. If you know the original ratio, how much parent and daughter elements were there at the beginning, and then if you know the decay rate, and then if you know that nothing's been added, nothing's been removed, then you could calculate that. Of course, you don't know those things, but if you did, then you would be able to make a calculation. Well, with regard to radiometric dating, we could ask, does it give correct dates for items that we know how old they are? Items of known age. So for example, here, this is the lava dome in Mount St. Helens, and so less than 35 years old. How old does it date? 350,000 to 2.4 million years. I think that's by potassium-argon dating, if I remember. Or what about the consistency of ages? If you use different radiometric dating techniques, like uranium-lead, and then you also do potassium-argon or something like that, they should agree. And yet, sometimes we see these inconsistencies. Here, like this one here. And so, see the person way up there at the top, and way down here, buried far below, is this basalt layer that dates 45 million years, but the wood that's buried in there dates 45,000 years. So clearly something is wrong with regard to the inconsistency in those ages. Carbon-14 in diamonds has been found. Carbon-14, of course, has a very short half-life. It should decay away to levels that are too small to measure in not very long. And yet, diamonds that are supposed to be very old, I believe coal has also been found to have carbon-14 in it. How can that be? If it was really that old, it should have all decayed away, or at least to levels too small to measure. Here's an interesting one. Here's kind of a cutaway section of Grand Canyon. As I understand it, most of the rocks in Grand Canyon can't be dated because they're sedimentary rocks. But there are some rocks that can be dated, like this kind of grayish one way down there toward the bottom that the red arrow is pointing at. That basalt layer can be dated. And then that lava flow up at the top that's sort of flowing down the side of the canyon, that can also be dated. And interestingly, the lava flow flowing down the side dates almost 300 million years older than the one buried way down there below. And so clearly there's something wrong there. Okay, now, no doubt, I'm sure that there are consistent ages. Otherwise, we presume that the people who rely on radiometric dating would have given it up long ago. And so there's got to be some consistent ages that they might point to and say, look, see, here we get consistency, and here we get consistency, so that proves that this is reliable. Well, it could be that it's due to something like psychological factors. As you recall, based upon uniformitarianism and the rock layers and things like that, my understanding is before people began to use radiometric dating, they already thought that the Earth was very old. And so that could have a tendency to influence how people interpret radiometric dating type ages. I heard a talk once where a person who had worked in a radiometric dating lab noted that one of the required pieces of information on the form when a rock was going to be dated was an estimate about how old it's supposed to be. And so you could easily see how people might have a tendency to react like this. Like if they get a spread of ages, they might go, well, this one's obviously far too old, and this one's obviously far too young. It must be that this is the correct age. Something like that. You could see how something like that might occur. Or even if that is not the whole story, maybe there's just something we don't understand. Maybe there's just something that we just don't get right now about radiometric dating. Maybe you've seen those recent findings on solar activity and the question of whether solar activity could possibly be affecting radiometric decay here on the Earth. And there's controversy. Last I heard about this, but I looked at a kind of a discussion of this, and based upon the technical stuff, I presume it was all physicists or whatever who were having this discussion, and one of them commented that, science is never settled, because things can come along and change our perspective on something that we thought we knew. And so, of course, that could be true as well, that something comes along and totally changes our view on radiometric dating, or the view that many of the scientists hold. Here's an interesting quote by Humphreys. "I estimate that there are probably several hundred processes that one could use to get an idea of the age of the Earth. Only a few dozen, at most, of these processes seem to give you billions of years. The other 90% of those processes give you ages much less than billions of years." And so he says if we use uniformitarian assumptions, there are many possible ways of dating that give ages much less than this. And so one should not necessarily assume that just because some dating ages give billions of years that those are necessarily correct. Then finally, let me sort of note this one example that really struck me as interesting with regard to Specimen Ridge in Yellowstone. Here's kind of a cutaway view of it, and as you can see, there's a number of layers with trees in them. And my understanding is that was viewed, and perhaps is still viewed by some, as layers of forests. And so you would have a forest, and then maybe a lava flow or something would come along and destroy that forest. Then eventually the area would begin to recover, and another forest would grow up above that. And then that forest would be leveled by something. And then another forest would grow after that, and then that would be destroyed, and then another one would grow after that. And I understand there's something like 27 different layers here. And so, of course, if that's really the way it worked, that would seem to take much more than 10,000 years for all that to have occurred. And if I remember in Morris's book, he talks about how one person saw this, and this was apparently part of what sort of led to his abandoning of his faith gradually because of this sort of thing. And I think that's really a sad thing. Well, here's a sign that I take it suggests that what I just mentioned about the forests, the forest grew up and then was leveled, and then another forest later, and so on. But the eruption at Mount St. Helens, I think, helps to shed light on this sort of thing. When that eruption occurred, it destroyed a large area of forest, and the logs kind of collected on Spirit Lake. Here you can see some floating there, and then you'll notice that some of them are floating upright. And so I guess that's because of different densities of wood, or how the roots get waterlogged first, or something like that. Anyway, and so they begin to float upright, and then they may sink and sort of ground themselves, as it were, in the sediment on the bottom. And so tree stumps can get buried in layers, and it might look like it had grown there. So my understanding is that the trees at Specimen Ridge appear to be broken off at the roots. They don't have these well-developed root systems that you might expect if they had really grown there. And so it looks rather like a single forest was destroyed and deposited in layers, kind of like what we can see now with regard to Mount St. Helens, similar to polystrate fossil trees, where they get buried upright across several layers. And I understand that the sign about forests growing and being buried has now been removed. And so I think that provides kind of a good moral or a lesson to be learned from this. Much evidence, as we've noticed throughout these presentations, much evidence supports the biblical view. I think there's considerable amount of evidence that supports the biblical view. But let's suppose that we're confronted with something that we don't understand. It seems to conflict and we're not sure how to explain it. Something like that, that's no reason to abandon one's faith, especially in light of all of the other evidence that there is. Perhaps there's or what it's probably that we just do not understand that particular thing. And if we just wait, it may be that science will discover what the answer is, and show, oh look, the Bible's been confirmed after all, just like it has been over and over again with regard to various types of things. And so, even if one doesn't understand something, that's certainly no reason to abandon one's faith. Before closing, I would like to note what the scriptures say about how to be saved, how to become a Christian, and how to eventually reach heaven by the grace of God. And so God loves people. He wants everyone to be saved, doesn't want anyone to be lost. And the scriptures tell us what to do, because he has provided a way of salvation. We have to believe that God exists and that he rewards those who diligently seek him. We have to believe that Jesus is the one that he claimed to be, that he is the Christ, that he is God's Son. We must repent of sins, that is, have a change of mind that leads to a change of life. We turn away from sin and turn toward God. Confess one's faith openly in Jesus. And then be baptized, immersed in water, in the name of the Father, the Son, and the Holy Spirit for the forgiveness of sins. I'd like to pause there for just a moment. I realize that there are many in our society and even around the world who hold that baptism is not a part of salvation. And they may think it's not really important at all, or they may think that it is important to do, but it's not involved in salvation. And they may think that it is a work, and so cannot be involved in salvation, because salvation is by grace through faith. And I certainly believe that we are saved by God's grace, and we cannot merit salvation in any way. But I believe that God has told us what to do to receive the grace that he has extended to everyone, and that includes baptism and believing and repenting and confessing. And if you do not believe that baptism is involved, I would invite you to contact me. I would be eager to talk to you about those kinds of things. And I would also ask you to consider various passages like 1 Peter 3:21, or the first part of Romans chapter 6, Galatians 3, verses 26 through 28. Or you may recall in Paul's account of his conversion in Acts chapter 22, when Ananias goes to see him. He's already been fasting and praying, and yet still, so obviously he believed, obviously he had repented, he felt sorry for what he had done and wanted to do what God wanted him to, but what did Ananias tell him? Arise and be baptized, wash your sins away, calling on his name. And so it seems clear to me that baptism is involved in salvation. But then, even after one has believed and repented and confessed and been baptized, one becomes a Christian, one is baptized into Christ. But that doesn't mean that one is guaranteed of heaven. One has to continue to live a faithful life. Now, of course, we being regular people, we're imperfect. We mess up, we fail, we make mistakes, we sin, we do wrong from time to time. And fortunately, God has provided a way for Christians to be forgiven. Once a person becomes a Christian, then Christians can confess their sins, and God will forgive. And so I would encourage you to take note of that information that the scriptures are telling us and behave accordingly.